Thank you very much, and good morning from my side as well. And as Anne kindly introduced me, then yes, I am a sort of space law person since a long time ago, and got into cyberspace also. So this is a really fantastic topic for me, my favorite topic, one of the few things worth getting up for on a rainy Friday morning when you've all been to a party last night. But I'm sure it will be well worth it. How we will do it, I think, is we will have about 20 minutes for the speakers, and then one or two relatively short questions immediately after the talk if you want to address something exactly that speaker said, in order to keep some time for a discussion at the end. So bigger questions, as I think will be more interesting actually when we've heard three a bit different perspectives on this extremely topical and interesting issue. As you will hear, it is something that, cyberspace and space are talked about a lot because the two influence one another when it comes to rulemaking and so perhaps especially for lawyers, but also for others generally, how do we deal with these issues? But also more and more we see how we need to think about cyberspace in space and maybe space and cyberspace. So those are the topics we will have from different angles, the business world, the military world. But we will start with James. So James Pavur is an Oxford PhD student and looking at satellites, space-based systems, security of them. And I think, if I have got it right, the name of your talk will be The Impact of Cyber Weapons in Outer Space. So please, I give the floor first to you.
Walk back here real quick. Thanks. Hi. So yeah, I'm honored to start off this presentation with a paper entitled The Cyber-ASAT, ASAT meaning anti-satellite weapon, that kind of theorizes about the strategic effect of cyber weapons in the domain of outer space. Space is important to kind of NATO audience. This might seem obvious, but since the earliest days of the space race, there's kind of been a recognition that space has this unique allure to military strategic purposes. Lyndon Johnson, when he was a senator in the earliest days of the space race, said control of space means control of the world. And this kind of embodies the tantalizing myth of space as an ultimate high ground, that whoever controls the heavens controls the earth, the sea, and the sky. And whether or not this is completely true, it has become clear that space is a vital component of how modern militaries approach warfighting and strategy. This was particularly demonstrated by the overwhelming victory of US and Allied forces during the Gulf War, when space-based systems are widely attributed for providing unprecedented C4ISR capabilities, so the ability to communicate to individual warfighters, to have unparalleled intelligence from imaging satellites, and to have precise positional information. Given how important space systems have become, it's kind of strange that this number here is 0 by my count. People aren't attacking satellites in the status quo. We're not seeing satellites blow up in every battlefield operation. And this doesn't make intuitive sense. Satellites are extremely visible. You just need a telescope to know where they are. They're fragile because launch costs are difficult and expensive. They move very fast, which means a small piece of debris can do serious damage, and they're not operationally responsive. Once a satellite is destroyed, it may take months or years to replace it. So in this presentation, I'll kind of start out by asking the theoretical question about why this isn't happening, why there aren't space wars in the status quo. And I'll draw out three kind of arguments from the literature that argue why we aren't using kinetic ASATs. And then I'll build on that with the cyber context, thinking about how a cyber anti-satellite weapon might interface with these same domain features. And I'll contend that there are differences in cyber weapons that are particularly concerning from a space perspective and might have concerning impacts on space strategy. However, this presentation is explicitly interdisciplinary. I come from a mixed background with some IR stuff, as well as I'm doing more technical computer science work now. And so I wanted to put this to the test as well and build a simulated CyberASAT capability. So we also kind of look at what this would be in practice. We walk through simulations where we design a CyberASAT weapon to get a feel for what one might look like and a feel for how difficult it would be to develop these capabilities. So the first theoretical constraint against space wars is a very intuitive one, and that relates to accessibility. This is a picture actually from something that happened after I published the paper. This is the recent Indian anti-satellite weapon test, and it's kind of your traditional kinetic ASAT. You have a rocket that's full of fire, the fire pushes something hard into orbit, which crashes into a satellite, breaks it into a million pieces, mission accomplished. As simple as that sounds from that kind of glib explanation, this is literally rocket science. And as a result, there aren't many countries that have this capacity. Depending on how you count, specifically within the EU, there are about 10 or so countries that have domestic orbital launch capabilities, the ability to put anything in orbit themselves, whether that is a space system for research or for imaging. And then within those, the subset of countries that have offensive capabilities is less than half. We're talking about 4 countries that have demonstrated the precision and finesse to use an offensive anti-satellite weapon kinetically. That's China, the US, Russia, and most recently, India. Even when you get this far, even when you have a national space program, even when you know how to use it to attack a satellite, you still might not like doing so for the simple reason that it's very expensive to have a meaningful intercept capability. The cost of taking out, say, 3 or 4 key satellites is multiple rocket launches, potentially spaced over multiple days, and we're talking about an operation that scales towards the billions of dollars end of the spectrum, which means except in scenarios of extreme need, kinetic ASAT is not necessarily very appealing. If we contrast this with the kind of cyber context, you see that the baseline threshold is met by all countries already. Everyone has access to computing technology, everyone has access to the internet, even non-state actors can kind of play in cyberspace. Moreover, a recent kind of offhand media remark by an NSA official estimated that there are about 100 countries with offensive cyber capabilities that are of concern to the United States. Now, there's a whole range of capacities within that list of countries, but I think it's fair to say that in general, a country is much closer to an offensive cyber program than they are to a national space program. And once you have that cyber program, once you have the expertise to build cyber weapons generally, the cost of a specific operation might be on the scale of hundreds, tens of thousands of dollars, maybe acquire some 0 days or hire some domain experts, but it's definitely not the same thing as launching a rocket. The next kind of general constraint that is talked about in the literature against kinetic ASATs is a normative one. This map behind me is a map of signatories to the Outer Space Treaty. Countries in green have signed and ratified it into their national law. Countries in yellow have signed it. And the Outer Space Treaty, if there's one bit of consensus in the space policy literature, is not perfect. There are a lot of problems with the treaty, but it attempts to ban weaponization and militarization of outer space. And it's been around for a long time and has been widely adopted. 100+ parties have signed it, including all major spacefaring nations. And so as a result, it has an influence on the way states approach the use of kinetic anti-satellite weapons. Specifically, when states break the rules, when they push the boundaries, they do it couched in legal rhetoric, citing the Outer Space Treaty and talking about why it's justified, say, to remove hazardous materials from orbit that could threaten civilians, or because whatever they did is technically not a weapon, which kind of demonstrates that states feel a need to explain their misbehavior with kinetic ASATs in a way that they might not with CyberASATs. Moreover, states feel this need in part because they know they'll get caught. Attributing a rocket launch is not very difficult. There are only so many places you can launch a rocket from. There's a lot of fire. There's a physical effect. You can have photographs like the one I just showed you. So states feel a need to justify what they're doing and to be sure they're willing to pay those diplomatic costs. In the cyber context, things are, again, pretty different. We have the Tallinn Manual, and we have some kind of international agreements on best actions and best practices in cyberspace, but we don't have anything like the Outer Space Treaty that's been codified into hundreds of countries' domestic law. And there's a long way to go in norms generation and perhaps lessons to be learned from the Outer Space Treaty, but those lessons haven't been put into effect yet. Moreover, states have demonstrated that they are fine pushing the boundaries in cyberspace. Whether this is US surveillance on allies, or Chinese state-sponsored hacking of companies, or Russian interference in the US elections, it's very clear that the rules, to the extent they exist in cyberspace, are still very malleable, and states are willing to take risks and kind of push the limits of what's acceptable. And part of this is because they think they might get away with it. Attribution is not as easy in cyberspace, even if it is possible, as it would be in an outer space context. There's a lot of plausible deniability, there's a lot of room for refutation that you simply don't have when someone has a video of a rocket leaving your country's spaceport. Finally, the last constraint I'm going to talk about relates to the space environment itself. So this animation behind me is debris that was generated by the 2007 Chinese ASAT test and 2 other debris-generating incidents. Each of these dots is an existential threat to a satellite. These are pieces of metal or different orbital components that are flying at thousands of miles an hour, and if they collide with a satellite, they could cause it to disintegrate or to deorbit and stop functioning. As a result, when you launch a kinetic anti-satellite weapon and you break a satellite up, you add more pieces to this sphere, and that poses a high risk of collateral damage to your own space assets from this generated debris field, which is also highly difficult to predict, especially over the long term. And the long term matters because this debris will remain in orbit for potentially decades before it enters into the atmosphere and burns up. So even if there's a short-term benefit to a kinetic ASAT attack, that also has to outweigh the long-term costs to doing so. And everyone who could cause harm with the kinetic ASAT cares about this kind of thing. These are all spacefaring nations who have an interest in being able to use orbit themselves so they can get the benefit of that massive investment in a national space program. And so they're shared stakeholders in this ecology. If we look at the cyber context, things are again pretty different. You can imagine a zero debris counter space capability with cyber attack. For example, disabling one key sensor on a satellite system or eavesdropping on communications without necessarily directly damaging the satellite. Moreover, a cyber attack can be constrained and time-bound in a way that debris cannot. You could turn off a satellite for 3 key hours during a battlefield operation without permanently damaging it and having an impact on the environment. And finally, many of the attackers simply don't care about the space environment. If you're a small country that doesn't have a space program, you might view denying access to space to the United States for the next 20, 30 years as an upside to a cyber attack, because now they no longer can exercise those asymmetric advantages that space offers the powerful. So we've kind of made a theoretical case here that accessibility, deterrability, and the space environment have constrained the use of kinetic ASAT weapons, but that these same domain features are not as powerful with respect to cyber attacks on satellites. This is all to say that security in space won't come naturally anymore, if it's ever come naturally. Being able to defend satellites against cyber attacks will require conscious effort from industry, academia, and the public sector to consider these threats as a real and emerging change in the way domain operates. Rather than leave it there, this talk has been given many times. Essentially every new invention in space technology, whether it's an improved launch capacity or better precision, has been prophesied as bringing about the next era of space wars. And rather than immediately add my name to that ash heap of incorrect predictions, I'd like to kind of test this a little bit and get a better feel for what a CyberASAT might look like. So we've designed a case study where we try to simulate a CyberASAT. We make some pretty generous assumptions to keep the case study simple, but the hope is to kind of get a feel for what this might look like so we can get an idea of what defending against a CyberASAT might look like. So our target in this simulation is a component of spaceflight operations called space situational awareness data. It was used to generate that image I showed you earlier of all the debris objects. Essentially, countries like the United States, Russia, and China operate distributed sensor networks around the world where they use radar and lasers to track debris objects in orbit and try to guess where those debris objects are going to go over the next couple of days. These estimates are then fed into a centralized repository of kind of orbital projections and characteristics, which are shared with third parties. These might be third-party spaceflight service operators like AGI, or these might be directly with satellite operators themselves through alerts or via open source APIs like spacetrack.org. And these projections are fed into a spaceflight operator's flight control systems. And they look for which debris objects might be coming near their satellites over the next couple of days, and they plan maneuvers if there's a debris object that poses a threat to avoid those objects. This isn't ideal. Every time you have to move a satellite, you use fuel, you increase risk of a mission failure, and you increase the cost of the mission. But it's definitely preferable to having your satellite get hit by a debris object and disintegrate. Our target for this attack isn't some esoteric space system. It's the stuff in red here. This is the bread and butter of cybersecurity attacks. It's databases, information at rest, it's network connections, information in transit. Our threat model is pretty straightforward and pretty generous to the attacker. First, we say that the attacker has gained some ability to influence stuff within those red dots. They either have found a 0 day in a database, like an Oracle database or something like that, or they're a man in the middle, or maybe they are the organizer. Maybe they are the people who are actually operating the database. So you could imagine, say, that you were Iran and you depended on the United States for space situational awareness data. You might not always trust that data if the US starts lying to you. Additionally, we make a very generous assumption, which is that space situational awareness data is not subject to additional verification. So in the real world, if there's a debris collision projected, you can call up the JSPOC and be like, you said this debris object is going to come close to my satellite. Can you verify that with additional sensing, or can you check this reading before we undergo a maneuver? We assume that this either doesn't happen or that the attacker has found a way to manipulate the results of that second verification stage as well. And then finally, we do make the attacker do some work. They can't just invent debris objects that don't exist. They can't cause things to teleport. They need to try to be stealthy with the actual changes they make to this data set, with the goal of not getting immediately caught. In the theme of silent battle, we're going to try to have a silent attack. So our goal is to take something that's not going to collide with a satellite in the future, so a near miss event, and make it look like it'll be a collision. This has the benefit of potentially causing a satellite operator to move their satellite when they don't need to, which increases the cost of their space missions, shortens the lifespan of the satellites, and is kind of a slow burn effect, right? This isn't a catastrophic impact that generates debris, but it's the sort of thing a country might want to do if they're hostile but not in conflict to one of their adversaries. You can imagine a much worse version of this scenario using the same kind of mechanism, which would be where an attacker takes a projected collision event and conceals it. This could cause a short-term catastrophic failure, but it has the risk of generating a debris field, which may be acceptable to some adversaries, is unacceptable to others. The data we target in our simulation is stored in the format of a two-line element set. This is a widely used format for describing space objects' orbital characteristics. It was developed to actually use with punch cards on mainframe computers, which is why the format has so little information, but it's surprisingly accurate. Depending on how you propagate it, you can get about 1 kilometer of precision over a 72-hour period using widely available propagators. Our attacker will only be allowed to change these fields in the two-line element set. The idea being that if we limit what the attacker can change, we limit their effects, the risk of detection. And further in our paper, we actually outline also magnitude constraints on how much the attacker is allowed to change these fields. The first job the attacker has is figuring out which of the elements in this database of thousands and thousands of orbital objects are the best to change. So we call this our acquisition phase. This animation behind me kind of shows how we do this. So we have this sphere around our satellite, which is 1,000 kilometers in diameter, and we propagate the satellite that's going to be our victim for a 72-hour period. As one of those white dots enters the sphere at the height of the satellite, we then try to find its time of closest approach and the distance where it is at closest approach. The 5 objects that pass closest to the satellite are our candidates for manipulation that the attacker will try to target. In the next stage, which we call the perturbation stage, the attacker uses a genetic algorithm. So he treats the two-line element sets as a genome sequence, in essence, and tries to modify the characteristics of that two-line element set with 2 metrics of fitness. The first is the closest pass. So they want to minimize the distance that that object comes from the satellite over the next 72 hours. The second thing that they try to modify over this genetic process is to minimize the amount of change they make. So these are our 2 metrics of fitness, and together we eventually find a scenario where the debris object falls within that zone of uncertainty surrounding the estimate. For our simulations, that was a 1 kilometer pass, but we actually found that it could probably be reduced down to 200 meters with a little bit more computing power and a larger debris field. Once you have a near miss scenario, or once you have now a collision scenario, you propagate that back into the database. So you put it back in the two-line element format in our generation phase, and you change the entry in the database very slightly to change the projection pretty dramatically from a non-collision event to a collision event. You'll notice here that these fields have been slightly modified. The underlined in red are all of the changes, and these are within constraints that are configurable. The attacker could then put this into the database and potentially impact spaceflight operations. So in our simulation, we targeted the Iridium satellite constellation in those orbital projections I showed you, which has 111 critical communication satellites that are widely used by military and commercial operators. And our debris field was very small. It only had about 500 debris objects. There are actually thousands of candidates in space. The reason we kept the debris field so small is we wanted to do this on consumer-grade hardware. So this was done on kind of your standard commercial laptop, not any sort of sophisticated supercomputer technology. And we found that we were able to find a malicious collision event over an arbitrary 72-hour window with a 93% success rate within 15 minutes of running the attack. So this is all to say that the core of this attack is not beyond the means of any particular adversary. Once they've gained access to those databases, which may or may not be difficult depending on the operational nature of those databases, moving that to an ASAT capability is potentially not as difficult as one might believe. Now, I don't present this as a great way to attack satellites. My hope is that nobody in the room is about to scurry off to their offices in a panic. Ideally, the spaceflight operators understand that there is a trust relationship in using SSA data. Ideally, the JSPOC and NORAD understand that their databases are potential targets for attack. Rather, what I'm trying to do is present the case that a simple, traditional cyber vulnerability on the ground, something that's not a specialized space system, something that's not particularly unique or novel, can have a novel impact in outer space. It can have those strategic effects that we were talking about earlier. And that such attacks are within the means of a broad range of potential attackers. So to kind of wrap up this scenario and this thought experiment, we've argued that a CyberASAT weapon could have a dramatic impact on the strategic balance of outer space because it's not constrained by the domain features that have traditionally made kinetic ASATs less appealing. Moreover, we've argued that emerging threats might be able to take advantage of this. Cyberspace is a place where more people can play more effectively, and having an impact in space is no longer limited to just spacefaring nations, but to smaller nations and to non-state actors as well. That said, we've also found that the attack surface of space systems is something that still needs a lot of characterization. A lot of the knowledge in this domain is siloed behind classification barriers. It's not publicly known, or it's behind very distinct and proprietary systems. And at least personally, I'd argue that there's a real need for a research push to get a sense of what makes satellite information systems technologically unique. What kind of things might require specialized academic research or specialized industry research that would benefit from the wider cybersecurity community. However, there's also a point to be made here that there's some aspects of this attack and generally space-based systems that aren't unique. There's a lot that space has in common with other domains, whether that be other critical infrastructure domains that rely on specialized systems, or whether that be just general information systems. And so there's also value in finding the aspects of space that aren't novel and that aren't unique, and seeing where lessons from other domains might be applied effectively there. What kind of general approaches to cybersecurity need to be applied in space, and how we can apply those. So hopefully this presentation has given you all some food for thought and given the panel something to disagree with or discuss. I'm glad to be here and happy to answer any questions.
Thank you. Thank you very much, James, for an excellent presentation, very thought-provoking. And what came to my mind is how with space there's a lot of things that are kind of talked about, and they don't really happen, but then at a certain point they start happening. It's the same with private use. So do we have one or two short questions? We will have the other presentations and more time for discussion later, but if there's anybody who wants to address like rather some clarification or something like that, for discussion we'll come back later, but if you wanted to. Oh, okay. In that case, we'll move on with the next speaker. That will be Mr. Robert Drowsing, who is from Airbus Defence and Space, Head of Product Security for Space, so dealing with protecting space against cyber threats. So now you can say what you're going to do about this when it all happens. You're actually going to talk about cyber and space, full life cycle protection. So I think that fits very well with sort of shooting down the plan of James here. So please,
exactly.
Floor
Thank
is
you.
yours.
Good morning, ladies and gentlemen. It's a pleasure to be here for the first time and speak on behalf of my company. I'm representing the other side, in that case, basically the industry, who has to build, maintain, and operate spacecraft. I'm from Airbus Defence and Space. As some of you might know, Airbus is not only building aircraft and helicopters. No, we are also the #1 company in space in Europe. We are also the #1 supplier in the world of what we call Earth observation satellites. And we are home-based across 7 European countries. And we operate at 16 sites across these European countries. The 16 sites, I will come back later, is one of the current targets of our activities. And I will show you in a minute what that means. So, what are our areas of concern? What you see is there is a need for more interconnectivity of spacecraft, and spacecraft-to-ground communications are more complex over time. We're talking now about new communication links like an European data relay highway in the space system that is transmitting data from satellites to the Earth at high speed. And it's based on laser communication. The question is, this connectivity, is it secure? Can it be compromised? So this is a question that we are posing currently ourselves. Also, we have very complex components in our spacecraft, not specifically designed to be secure. Some commercial off-the-shelf systems. We're going more and more into this new space area where speed and cost matters. So away from bespoke systems to commercial off-the-shelf systems, building smaller satellites for less cost. What also is a good thing for us, our products last very long. We have satellites in orbit that are 10, 20 years in orbit already. They have been developed for a long time before that, so we are talking about very long time spans where our systems are exposed to threats. When we designed these systems 15, 20 years ago, we had no idea of cyber threats. The threats scenarios were evolving over the last few years, and we have to cope with that and protect our systems. The question also, who is responsible for the security of such a product, such a satellite? Is it us as industry and as a manufacturer? Is it the operator of a satellite later on? Is it in the civilian space or even in the military environment? Who takes care of protecting the system against cyber threats? We have a big topic currently, which is especially unique in the European Union. One of our big customers is the European Space Agency. The European Space Agency has a unique concept they call geo-return. That means we, as one of the 3 large prime contractors in Europe, we will get the contract, the prime contract for a spacecraft, but we have to involve a large number of SMEs, small and medium-sized enterprises across Europe that will build and assemble and design components, and we will have to integrate these components. So our supply chain is very deep and very wide. And the question is, how can we secure this supply chain to make sure that a single supplier in some new European member state country of ESA is delivering some kind of small software, a software module that we integrate later on our satellite or in our satellite mission control systems? How can we make sure this system is secured? Yes, we have also some new customers coming, traditionally institutional. We know that from in a military environment, we get clear security requirements from our customer. Our customer is also willing to pay for this, the implementation of these requirements into our system. But now, as I said, new customers coming in, maybe security is not the top topic, maybe time to market is a high value for them, and we have to make sure that we also educate our customers in the protection of their assets later on during the life cycle of their, in that case, spacecraft. So, what threats are we facing to our products? You see on the top left, we have the modes of attack. As we have seen, very new modes of attack are popping up all the time. We have, of course, traditional threats to our spacecraft, like jamming, like spoofing of signals, for instance, GPS signals, which is around for a long time. However, we see now more and more coming up a cyber threat. The cyber threat not only in the traditional IT world, but also in the ICS world, in the control systems, in the tools we use to build our spacecraft. So there is the risk increasing significantly. I will tell about that in a minute. And also then we have what we see now in different phases of the spacecraft life cycle, threats that were never envisioned that way, like in-orbit vulnerabilities. So we have threats to our spacecraft when they are operated in orbit. One might be a cyber threat, but we have also physical threats by, let's say, co-orbital spacecraft operated by some other nations that approach our spacecraft and can do direct harm to our spacecraft. We have to protect against this one also. So, who are the threat actors? We as Airbus are one of the prime targets, unfortunately, for all kinds of threat actors, starting from script kiddies, hackers who attack our systems every day, all the way up political activists, terroristic attacks, organized crime, up to state actors. What is the impact? The impact if such an attack is successful on one of our systems, we have eventually laid a route to attack to our customers. If a spacecraft is attacked, it can affect maybe the systems of the customers. We can lose the product. in worst case, if you have a successful attempt attacking our spacecraft, you might lose it. We could also lose the product integrity, so there could be falsified information coming from the product, from the spacecraft. We could lose our intellectual property, which would be not so good for us. There is threats that might be dormant through the whole supply chain, as mentioned before, that we don't know, we have not detected, and it might explode into our face at any given time. And also, we might lose customer information, customer data, or even worse, ITAR data, control data, personnel data. That would be also a significant consequence for us as a company. You see here some consequences: loss of customer confidence, a direct financial impact if you lose a spacecraft, but also worst case, safety of the product or even safety of life. I show you some of the products we need to protect. So, to cope with all this, our company has established about 4 years ago an internal organization that is called Product Security Office. I'm in charge of the Product Security Office for our space systems activities, and our mission is to protect all our product against cyber threats throughout the whole life cycle of the product. This starts with very early R&D phases, up to definition, development, implementation, industrialization, operation, testing, maintenance, and support during the actual in-orbit operational phase, and also, important to us, disposal. As you might know, we have to guarantee that our spacecraft will be disposed at the end of the lifespan, either by controlled deorbiting of the spacecraft, or by sending spacecraft that are in a high geostationary orbit, we send them to a satellite graveyard. But we have to make sure that there's no harm coming from the products later on. So this is the mission of the organization. What is a product? To us, a product is not only a satellite we deliver to a customer or a launcher like Ariane 5, but it could be anything that is a component, a platform, a subsystem, a payload, a software, a service. We are more and more going into services, but also even a documentation. So we have to protect it 2 ways. One, nobody should steal our intellectual property, and also nobody should inject malware at any given time into our product. So this is what we do with a product. And then we have a second thing that we are currently focusing on, which we call product industrial tool systems. This is the complete tool chain we need to develop, design, build, test, maintain, and operate our products. This is mostly non-standard IT equipment. We call it OT equipment that is in our clean rooms, in our assembly, integration, and testing facilities located. Special, we call it special checkout equipments, for instance, systems that are connected to the satellite during the design, test, and operational phase later on. So we have specific checkout equipment, we have mission control segments. So all these systems are there to support the satellite. Some of the products I would like to show you we are dealing with here. I see here one of our products, which is a telecommunication spacecraft, a telecom satellite in geostationary orbit. We always thought that at an orbit of 36,000 kilometers, the threats are not so big. We have done stringent risk analysis, and currently we are evaluating all kinds of vulnerabilities also at that orbit. So ASAT weapons, as mentioned before, might be capable of reaching this geostationary orbit soon or even already. So there is a risk, even high out in space. On the low Earth orbit space, we have here a series of satellites called Copernicus, which is a program from the European Space Agency. It's a very good program. It's an Earth observation program monitoring the Earth in different ways. It's monitoring biomass, it's monitoring waves, it's monitoring wind to get a comprehensive picture on our Earth, consisting of a large number of satellites. We were fortunate to win a number of those contracts and produce this spacecraft. However, this spacecraft are delivering important data. We have to make sure that the data integrity is guaranteed, so that later on, when this data is used for scientific analysis, the data that comes down from the satellite is really the data that the satellite has taken. Manned spaceflight. As you might know, we have built the European Columbus module as part of the International Space Station. Last year, we have celebrated 10 years of in-orbit time of the module. So we see astronauts there on orbit. It's a very, very challenging thing. We also operate the Columbus module from the ground facility. Inside this Columbus module, you see, for instance, a brand new thing we call Simon, which is a flying little robot connected to IBM Watson's artificial intelligence from space, and is a personal companion of an astronaut. Can support the astronaut in vital activities, can answer questions in real time, can also do other things like playing the favorite music of an astronaut or telling jokes. So we had this little robot in orbit. Lately, he was supporting Alexander Gerst, the German commander of the International Space Station a few months ago. So, however, this is a very interesting product, but it's connected directly to the internet. So, in space. And also manned spaceflight, the new American Orion mission. We are supporting the Orion mission by building the service module. And we are building our own launcher, the European launcher. It's currently the Ariane 5, and underway and soon to be launched is the Ariane 6, a brand new generation of launchers. Also, my colleagues at Ariane Group, which is a joint venture between Safran and Airbus, they are taking care of the cybersecurity of this launcher. And last but not least, a new challenge for us. There's a joint venture with OneWeb, where OneWeb would like to bring internet, high-speed internet, to the whole planet by a large-scale constellation of low Earth orbiting satellites. So the constellation in the final phase will consist of about 950 satellites, and will cover the whole Earth, as mentioned, with high-speed internet. Imagine if you have a cyber attack on this constellation of 950 satellites, and the cyber attack for any reason would be successful, you'll have, worst case, a lot of space debris. So we're taking a lot of measures to protect these constellations. How do we protect them? This is a small print, sorry for that, but this is showing the full life cycle of a typical space product from very early stages up to R&D, then defining a proposal, designing a system, building the system, testing the system. We spend a lot of time in what we call assembly, integration, and testing in our clean rooms, because as soon as the satellite is launched and in orbit, it's very hard to reach. Yeah? You would need some kind of service satellite, which is not there yet. So we have to make sure that the satellite is capable of performing also under situations that are not foreseen. And all the way to the end, we have the operational phase, which is very important. It becomes more and more important for us to protect the operational phase of the spacecraft. And all the way in the end, we have to take care that we secure, deposit the spacecraft. As I said, either burning up in the atmosphere or moving it to a graveyard orbit. And the thing is, we would like to be the people who deorbit the spacecraft. I would not want to have a hacker deorbiting my spacecraft by hacking into my satellite. So, what are we going to do about that? We have a wide range of activities. We do a lot of security risk assessments currently. We're putting security requirements into our products. We design secure architectures and design new ways of protecting our spacecraft. Also in the operations, we look into how can we protect our operations. And we have a wide range of activities with our colleagues from IT security, from site security, from digital security. We all work very closely together to ensure this security. One thing I would like to show you, one specific activity is secure one of the chains we have here, the chain from enterprise automation systems, everything that runs our buildings, for instance, air condition. We have a large need of clean air in a clean room, of course. We want to make sure that the air condition system in such a clean room is protected. Nobody can hack into the system and, for instance, change the quality of the air. That might be not very good for a satellite. Also, fire suppression systems, power systems, etc. The second big step we are doing is look into all our product industrial tool systems. That are the systems we need to build, test, maintain our satellites. We do a very large effort currently. And in the end, the last thing is this all flows into the product itself, the satellite. So, what are we doing? As mentioned, we have 16 sites in Europe where we build satellites or satellite payloads or equipment. And we go currently from site to site and do a thorough risk assessment, basically based on an ISO 27005 risk methodology. And we, together with our business owners, we decide what are our critical assets or crown jewels. We do a risk assessment on them. We have here a little risk table that shows if the impact and the likelihood of such a risk is high, then we go very deep. And together with our business and the stakeholders in our company, we develop risk treatment plans. And this we do at every site for all our BITS environment. That goes down to SPS systems, to robots, to CNC machines, to special checkout equipment, etc. A lot of action. We have done a lot of this already. We have seen a lot of interesting facts, legacy systems that are not so well protected to today's standards, but we do that ongoing. This is an ongoing plan, do, check, act cycle. So we're working hard on that. So what do? Our job is to ensure that the appropriate measures are in place to protect our products and services. How we do it, we have a holistic approach. We have also all the governance in place in our company, and also we do it for our customers and make sure that our products are secure. So, thank you. Question, please.
Thank you very much, Robert. It seems you have your work cut out for you anyway, especially after having had all the attacks James planning on your system. So, yes. Do we have any short clarification type questions? Yes, there is one in the back there. So, if you would say who you are and make a brief question now.
Lucas Silvestre from Guard Time. Just a very practical question. Do you think the attack that James described would work? Or to be maybe gentler to your products, what are the types of failures that a customer would need to have, or what are the ways in which they wouldn't need to follow your guidelines to allow that type of attack to work?
So if I understand it correctly, what the customer would need to do. We are going and working closely with our customers, especially our civilian customers, to bring the awareness of cyber threats to their products, and we make sure that the requirements we get from the customer in the future will be at a certain level to make sure that the product is protected in the end. And for us, it's important that we have the requirements from the customers, because if we implement our own requirements, that might be below a threshold, and we would like, of course, if the customer is understanding the risk to the product and also might be willing to pay for a little bit more security in the product. So military customers fully understand that. Civilian customers, it's not so easy currently. We go out and do a lot of awareness campaigns with our civilian customers.
Okay, thank you. I think we can move now to our last speaker, last but not least, Lieutenant Colonel Henry Heren from the NATO Joint Air Power Competence Center. You are a strategist, and you are going to give us the military perspective, a holistic military perspective on these various threats and opportunities maybe as well. So please, the floor is yours.
I have no slides, so this is a more informal presentation, so I'm going to stay seated if that's all right. I have to start with a disclaimer, so anything I'm about to say, there's my views, not the views of the Air Force or the DoD or the US government or NATO or the JAPCC. I'd like to thank you for the opportunity to be here from the CCDCOE. It's always nice when someone seeks out your opinion. It's a good feeling. I had prepared formal comments. I had a speech all written. Having been here this week, I spent most of last night rewriting it multiple times because of all the things I've heard and the other keynote speakers and the other panelists, trying to adapt to what I've heard and what I've picked up from the other speakers and in sidebar conversations. I'm not going to use that. They say in the Air Force, flexibility is the key to air power, and indecision is the key to flexibility. So I've got some notes, and I'm gonna go through there. I'll start first with James's paper, or the academic research. I find this type of research crucial as we move forward. I think putting the time into research a project and to come up with conclusions is something that we will need as we continue to go forward. And I think the one thing I would add to that is that perhaps there's sometimes too much separation between the military side and the academic side, and we could always do more with collaboration. So as these papers are being developed to seek out military or even law enforcement professionals to get input in that front-loaded side of it, so that we get kind of the operational mindset versus just the technical aspects, even as accurate as the technical aspects of the arguments can be. James laid out definitely a way, and I appreciate his higher level thought into the research that you do have vulnerabilities in space due to cyberspace capabilities. And he demonstrated a way in which those vulnerabilities could be exploited. I think it's important that we focus on that it's just a way, right? He presented a way to attack a satellite. From a military perspective, I may not always be concerned with the satellite itself, right? I might be concerned more with the payload, some of the things that Robert talked about, the service, the capability on the satellite. And so there's going to be cyber vulnerabilities to those types of things as well. So when you look at the approach, the specific research that James laid out, I agree with what he said. I think he said it was a slow burn, right? And so that's definitely a long game, right? That's something that you're not going to do overnight, that you're going to take months, perhaps even years to achieve an effect of an overall vehicle, which may be something that you want to do depending upon the mission that you find yourself in. But if you're trying to do something what I would term more operationally timely, more operationally relevant, something that's going to be quicker, you might want to focus more on the capabilities of the satellite versus the vehicle itself, which I think the research that you did leaves that open, that possibility. As far as the term CyberASAT, so I think this for me as a strategist by duty title, this is where I start to have concerns. And I've heard speakers this week talk about we can't apply cyber to every problem because not everything is a cyber issue, right? And so my focus when I start talking about ASATs is more on the ASAT piece. I think about how I either need to defend friendly satellites or attack adversary satellites, right, to inhibit their capabilities. The method in which I go about doing that is then a secondary or tertiary consideration, right? My focus, first and foremost, is on what I'm trying to achieve within my mission. So I get concerned within the cyber community, but also within the space community, when we see this labeling of space effects and cyber effects and CyberASAT. I think that puts us on a dangerous path. I say that because we start thinking about our capability first, and as we start thinking about that, it affects our thought processes, right? And those thought processes then affect the actions that we ultimately take, right? So if I'm going around thinking cyber, well, then I'm only going to look at everything through a cyber lens. And in an operational mindset, I don't think that that's going to necessarily be helpful in the long term, right? I need to take a more holistic approach. I need to start with the adversary, the effect I'm trying to generate in the adversary, and work my way backwards, and then look at the range of capabilities I have according to the mission constraints to achieve that mission, right? And that may very well be cyber, right? It may be a cyber capability. But when we put cyber, we do this in the space community, I think, too much as well. When we put those terms up front, I think we start off on the wrong foot. We're starting off at the wrong end of the problem and perhaps painting ourselves in a corner. In my mind, and maybe other folks will disagree, in my mind, the dangers in this, I think back to the 1990s. Within the U.S. Air Force, we adapted a quality mindset approach, right? There was a lot of business in the U.S. had taken some thoughts really from Japan, and the idea that, hey, we can do this quality approach to improve our processes, to improve the way we go about doing things, and it was a great tool. But that's what it was. It was a tool that you could use in some situations to make improvements, right? We went way overboard in this, and we got to the point where we had people walking around just living and breathing quality, and they started to mistake the mission of the Air Force or the mission of their organizations as a mission of quality, which was not the case, right? And it took us a number of years to work through that and for the pendulum to kind of swing back and for us to remember that our mission as the Air Force is not quality. That's simply a tool that we can use. So within the military, that's something that I get concerned about as I see us putting these labels of space first or cyber first. I think back to those difficulties we encountered that as a holistic military approach, I can't always put those things up front because then I start to lose focus on what my actual mission is. And it's easy to do right now, I think, because these capabilities, space capabilities, cyberspace, they're new. We're trying to grasp for an understanding of how they fit in, right? And it's not easy to wrap our nuggets around it, right? To really get into what it means to maneuver through cyberspace or to use fires in cyberspace, right? To produce an effect. We have a hard time picturing that. When we think of popular culture, we think, The Matrix, or we think of other movies or books maybe we read, but it's hard to draw those analogies. And so as we're grasping with those thoughts, we definitely need to make sure we're in the right lane as far as focusing on what we're trying to achieve. And there's a difference that I see for me looking at that versus the academic world or the commercial world, right? We have different approaches because we have different missions, right? James is out there trying to just produce new thoughts and get a better understanding of the world. Obviously, there's a commercial interest on the industry side, but for me, I don't necessarily have those same motivations, right? So the way in which I use the terms needs to be different if I'm going to be effective in my job. I think the subject of the panel here is space and cyberspace. So if I take a step back and look at how cyberspace and space are connected or how they're related, I really think it's within the bureaucracies of our governments, they're both information age capabilities. And it ties in with things that we do in the electromagnetic spectrum, and we had some panels yesterday on information operations or information warfare. All of these types of things, these areas in which we operate are new and not everybody understands them, and they're grouped together, and they don't have champions. They don't have services. We have armies, we have navies, we have air forces, right? So within our separate countries, the nations are organized along those domains, land, air, and sea, and that's where the funding funnels into, right? So those are the folks that have a seat at the table to be able to put forward an argument for capability or for concept development, right? They have that right through just historic precedents. But for space, for cyberspace, for EM operations, electromagnetic operations, information operations, they don't have a seat at the table, right? They're all secondary. They have to work through those folks at the table to get resourcing, to get funding, to really get a sense of importance. And that may tie to why we see so much of this labeling of space and cyberspace out in front of everything, because we're really trying to argue for a seat at the table, for recognition that we have a role to play. And again, I just think there's the danger that we could take that too far. But it's definitely something that we need to consider. And I think we need to be careful about really kind of having a sibling rivalry within those information age capabilities, right? We can't focus too much on one. I've heard arguments before, and I'm sure I'll hear them again, everything we saw in James's presentation, right? Space is all important, right? It's the ultimate high ground, right? But we also hear cyberspace. Well, everything is connected through cyberspace. You can't do anything without cyberspace. And again, this to me seems to just be another argument for that seat at the table, right? Hey, we're so important, please pay attention, give us a seat at the table, give us a seat in the discussion. But in doing that, sometimes we're nudging the other guys out of the way, right? The other guys that are also looking for that same relevance, that same ability to take part in the decision-making process. And one way that I think it shows up most importantly, and kind of circling back maybe a little bit, is into this lexicon idea, right? So CyberASAT, it's an ASAT. That's what it is, right? The mission is to go after a space system, right? The capability that I use to do that's a secondary thing. I don't need to get into that. We use kinetic and non-kinetic. Are those terms really applicable anymore? I mean, I think we've seen through real-world examples where you can use cyberspace capabilities and produce kinetic effects, right? So that's not necessarily helpful to us anymore. We have to look at the fact that the words we're using have real implications, right? There was a wise man in my community once said, words mean stuff. We really have to think about that. And so I think sometimes we need to take a step back and really listen to the words that we're using in these information age capabilities and try to have an understanding about those things. Are we making new terms up, making new words up because it's really something that's so different from the traditional military capabilities? Or is it that we're just trying to make it stand out, make it sound a little special? Are we using the words correctly? I don't know that that's always the case. And then lastly, and kind of sticking with this idea of the sibling rivalry amongst those, is we can't treat the different domains as utilities, right? We have to look at them operationally, right? What we're doing in space today is heavily reliant on cyberspace. And it's reliant on cyberspace as a utility, but that doesn't make cyberspace a utility, right? Cyberspace is an operational domain, according to NATO and according to many of the member nations. And space is an operational domain, not to NATO at this point, but to some of the member nations. So there's a difference between how we use these domains to conduct operations and then how we use them to support operations. And we can't lock ourselves into only looking at the supporting role. We have to be able to understand that there are times when these are supported missions as well, even from the traditional domains of air, land, and sea. In closing here, I'm going to end with a quote. Nietzsche once said, one must still have chaos in one to give birth to a dancing star. It's been more commonly rephrased to say, out of chaos comes order. And I think that's where we find ourselves today. We find ourselves in the chaos and the emerging and the developing and an evolution of these capabilities. And we're trying to figure out how they all fit together and how they fit into the world that we've known previously. And we have to be able to work together to bring order to all of this, and that it will eventually come. I think it'll come maybe by taking a step back and looking at the lexicon, looking at the words we're using and how we communicate with one another, and then finding our lane. What's our role, and being happy and comfortable in that role, and realizing that we don't have to set ourselves up as the utmost important contributor, but really as just part of a team player going forward. And that's all I have.
Thank you. Thank you very much. Now, as a lawyer who works on creating law for different types of technologies, what I'm always preaching is this that lawyers call technology neutrality, and that's really what you were talking about as well, not to focus on different terms. And so it's always nice to hear clever people say the same kind of things you say. So a short question or two to Henry before we open the debate and discussion generally. Any clarification points or anything like that? Well, if not, in that case, any thoughts, comments, questions to all of the, or any, or all together of our participants? I think what you said as well was very, very correct, and I think we should probably thank Anne, my former student, for that we have a very good panel that really combines different aspects. So are there any? I have many questions, but I'm not going to sort of use my privilege here to. Yes, we have. And we have a microphone coming, I think, and please say briefly who you are as well. So.
Okay, this on. Hi, Bill Britt, student UMBC. We have representative from industry here, and I know at least in the US there's a strong concern over supply chain security, resilience. The US Department of Defense has stated a term called deliver uncompromised, which is beginning to affect our industry. So as the industry perspective, you're having to build something as a corporation with economic interest at play, obviously, and then looking through your discussion on the military, I really appreciated that. I'm a former military, and the military bit into a lot of business theory early on. They're correcting back now, but how do you reconcile, for example, the acquisition process in which security and resiliency in both cybersecurity, space hardening, that sort of thing, the needs and requirements versus the cost?
Perhaps if you remember the question a little bit, maybe we'll see if there is another one. Just to, anybody else wish to add something? No, not this. You're still thinking about it. Okay, in that case, we'll go to.
Maybe, please. I can answer. Securing the supply chain is one of our top-notch topics currently. So, as mentioned before, especially in Europe, we have this unique situation. We have a very diversified supplier structure, and we have suppliers that are not very advanced in space business. They come from more traditional software development, for instance. So we are working together with our partners in industry, also with the partners and customers like European Space Agency, to make sure we have the nice a fitting governance process built into the supply chain. But we are at the beginning currently. So I can tell you a specific example. We wanted to test the Spitz approach to the supply chain. So I went to one of the suppliers of one of our main software component for our products. I checked with the supplier. He was in Denmark. Went to him and said, please show me, how do you protect your software? How can you guarantee the software you build and deliver to us is the correct one? It's virus-free. It's not changed, and all the integrity is there, and so on. He said, I can, yes, but only for what I have done, because this guy has a supplier who is developing a lot of the software, and this supplier was in a different country, in that case in Austria. So I went to the supplier. I said, guys, show me what you're doing. How do you do software development? How do you protect your environment? They were less advanced than the main supplier. And then they told me, but by the way, the main part of our software is not developed here in Vienna, but in Romania. So I had to go to Romania, to a very small company, have a look at them, yeah, and say, guys, you build a core element of my product. How do you protect it? And I was very surprised that they have a super protection in place. They were fully ISO 27000 compliant. So this was good news, yeah. But this is only an isolated case. So we need to make sure that this happens now for all the suppliers. Yeah? We need to have a process in place. So we are talking with other industries currently, like with the German automotive manufacturer industry, VDA. They have the same issue with the controls for their automatic control units. They control everything in the car. They have lots of different black boxes with software in there from different suppliers. They have invented a process over the last few years, and also a mechanisms to ensure that they have the right place of audits in place by external parties, and when they get the components and the software, this is built to an appropriate security level. So we think we will join forces with these other industries, see what they have done, take the best practices, and implement them in space.
I would add, I think, again, within this idea of information age capabilities, in many cases, we're trying to drive the car while we build it. And so within our structures, we use a structure actually going based from Napoleon, right? So the 3 function is the operations function, and the 5 is the planning function. And as we see these new capabilities come on board, there's always a push to get folks into the 3 as quick as possible, into the current operations. Hey, you've developed a widget, and we can use it because we have a match in the battle space somewhere out there where that's applicable, and we force that in there. The problem is with these new capabilities, at least from my perspective, is that a lot of times they're very specific, right? They're exquisite capabilities, and they're functional in a specific situation. And what we maybe should be looking to do is put more people in the 5, right? In that planning function, where you can get baked in to the long-term plans for military operations, and then that drives capability development through the requirements process, and then you can actually have a wider range of capabilities that are applicable in a host of military operations, versus starting with that exquisite capability and then trying to figure out different ways that you could use it. And that seems to be something that I don't think is unique to space or to cyberspace. Anytime we get a new capability, we rush it to ops instead of really letting it get baked into our plans. But when we do that, then I think then that goes to your question, that we're able to then handle those types of things.
Okay, I see a question here in the front.
Thank you. Tina Park from the NATO Defense College. I wondered if the panelists could comment about the role of artificial intelligence revolution as we ponder about cyber and space, because Simon, for instance, reminded me of HAL, and how potentially if a non-state terror group or some unknown entity intercepted, and in a hypothetical situation, if we had to make a decision, there is a human factor, but sometimes it may be unclear, or we may have to make a decision very quickly, and at that point, just as a layperson who is not an expert on space related capabilities, I wondered where we are, generally speaking, from your respective fields on dealing with new challenges coming from the AI revolution.
Maybe if you want to start.
Sure. So I'm not remotely an AI expert, but I guess one thing that I would talk about is we used a genetic algorithm in designing our attack, and for us this wasn't an AI paper, this wasn't focused on AI, it was simply a tool that saved me the trouble of having to learn orbital physics. And I think that AI takes a lot of that complexity and provides general purpose tools that might decrease the cost of understanding these esoteric domains.
We as a company taking a lot of actions currently into the research in AI, because we believe this is beneficial to us. Also, if you look currently, our spacecraft are not very intelligent. They are based on set of procedures and commands. And if you have a loss of communication, for instance, usually the spacecraft is acting very simply, going in a safe mode, for instance. We would envision in the future we have more intelligent spacecraft with some kind of AI capability to take decisions on their own, especially if they are on missions that are away from Earth, deep space missions. And we are looking at that deeply, but this is just at the beginning in this kind of research.
I'm definitely not an AI expert either. But I guess I would just echo what I previously said, right? It is coming, it's gonna happen, and how we integrate AI-backed capabilities into operations needs to be baked into the plans. I think there's gonna be a potential to change the way we think about planning. Right now, within the military, there's a big focus on command and control, right? And at the highest levels, right? We use, generals are watching UAVs, watching missions. There's a famous picture many of you may have seen with President Obama watching footage of the Osama bin Laden takedown, right? I mean, they had overhead, and he's watching that real time, right? But as systems become more and more self-dependent through AI capability, the adversaries are going to have that too. I mean, you have to assume that. And so you're going to have to command and control more and more as a planning function than as a real-time operation function. Because as soon as you start to put a human in the loop or keep a human in the loop, the human's not going to be fast enough to react, right? So we're going to have to readdress how we approach command and control. And we may have to look back to how it was done previously. I mean, you look in the Second World War, when carrier strike groups were sent out in the Pacific, they weren't command and controlled all the way through, right? They were given mission orders and sent off to conduct their mission. And we're going to have to figure out ways to think about how we do that with systems that are going to be similar. We're going to have to send them out and let them do their mission in a safe, effective manner. That's going to take a lot of trust. But it will cause us to, I think, to rethink how we approach operations.
Thank you. Any other questions? Yes? So wait for the microphone coming from the back there, I think.
Thank you very much. My name is Masato Shimada from the Japanese Ministry of Defense, and I'd like to ask to each panelist whether what would be the most dangerous scenario you may be able to come up with using a cyber capability to disrupt your space system or architecture or undermine your mission, if you may say. And in order to avoid such scenario, what we can do at this moment, today, to prevent such a worst case scenario. Thank you.
Worst case scenario, yeah. I don't know who wants to start.
I have a few, but I cannot tell about maybe you can.
I think the worst thing we could do is remain static, right? I mean, we've heard throughout the course of the week. Sorry, all the different comments from the other speakers kind of blend together at one moment, but we can do defense, and we can do defense to a point, but the adversaries, they're thinking and they're adapting, right? We're probably not going to see the same types of attacks repeated, right? Because they're learning as well. And so to stay static and think that our firewall, or Norton is going to take care of everything, that's probably the most dangerous thing. We really have to understand that this is an evolving security situation, and it will continue to evolve, and we're going to have to continue to adapt.
I guess I don't have any privileged information, so anything I can come up with I can say, which is refreshing. But I think that Robert's comment about the OneWeb network and these massive new space generation of satellite networks is really increasing both the amount of things we have in the orbit and the amount we depend on them. And space is something that the whole world shares. We only have one Earth and one orbit. And so a debris generating attack could really change our ability to use space for generations. And I think that is probably the most scary to me. But
yeah, I would add from my sort of space perspective as well that the one thing that sometimes is forgotten in the debate is that space is not interesting for space itself. Well, it is, it's interesting, but I mean, it's because all the things we do with it, and we do so many things with space. So, I mean, weather forecasting, disaster forecasting, it's the main way for the European Union to monitor use of agricultural subsidies, for instance, that's space. So, I mean, there are a number of things like that. So, any other questions? While you're thinking, I'll take the opportunity because I really want to ask this question myself. So I was just wondering if, to all of you, if that you see a point where the threat level or the possibility of bad things is going to get to such a level that will actually hinder development, innovation, because the threat is seen to be so big that it actually holds back innovation, or whether that point will then push for this kind of agreement, like you mentioned, what we have with the Outer Space Treaty, what will it be? Will it be that we say, whether it's the private business or even the military, that, okay, let's hold back, it's too dangerous, or will it mean that, okay, yes, we have to sort of put ourselves in a frame of rules and regulations? So very speculative. I am after an academic as well, so we can ask anything we like, and see, so any thoughts of that? Anybody?
I can tell you we see the threat levels rising rapidly in space, but on the other hand, we need to take measures to protect ourselves, so we are increasing protection levels. I think this is not necessarily good or bad, but this is a fact. Yeah, we have to do that, and I think this will continue on and will get worse in the next few years.
I can take a guess. I think that my hope is that there's a lot of positive changes in space as an overall industry. We're seeing lower launch costs. We're seeing a lot of commitment to using space technology. And I'm very optimistic that the magical promise of those technologies will be such that we're willing to face these risks head on instead of hide from them. I think that cybersecurity is something we've gotten actually very good at engineering on the ground. CyCon shows that there's a lot of really committed research in the broader cybersecurity area. And I think in outer space, there's potential for that, and it can protect that innovation.
I guess I would look at it and think right now it's such an uneven playing field in space, so that there's, really back to what James talked about in his presentation, that for cyberspace the threshold is so low, but for outer space the threshold is so high. And so as long as we continue to have that imbalance, there's always going to be that threat environment, but that as the technology develops and that threshold to outer space drops, will we get to that point before things go terribly wrong? I don't know. But until that, as long as that imbalance is there, then I think, there's a potential to be worried.
Okay, we still have some moments, some questions. Don't let this wonderful opportunity of having these different experts go lost. Come on, you must have some questions. Yes. Just in the back there, yeah.
Good morning. Yeah, from the European group, Miguel Tobias. So I have a question in reference with these tools provided by Airbus. So have you the intention to certify by the national security agencies these tools to provide the cyber protection?
So which tools are you talking about?
Yeah, so you say that you are providing some tools to certify that you can give this protection to the satellites and all the systems. So all this software that you like to implement is going to be certified by national security agencies?
Yes, absolutely. So there's a whole toolbox that needs to be employed. Yeah, but it's not only tools, but it's also governance and processes that needs to put in place. So in Europe, for instance, we have a certain process for space development. It's called ECSS standard, and this ECSS standard is currently evolving, and up to now there was very little cyber risk in the standard, actually almost nothing, and now this is changing. There will be an evolution of this whole governance processes coming up, but it takes some time. The governance is quite slow. It took us also 4 years to implement the appropriate governance. And now we are still not there. So when I write here full life cycle protection, we are just at the beginning to protect the full life cycle. It's a pretty lengthy process. And tools, of course, they're out there. Not an issue. We develop even our own tools in-house, but we buy off-the-shelf tools commercially. We work very closely together with academia to achieve that. But to us, it's a pretty long and tedious and costly process.
And in all this process for the products, so I attended yesterday a panel that they told about the obsolescence. So do you have in this product life cycle the obsolescence of the product, the need to update, and the running pace between operational needs and maintenance needs, update needs, and how to, because usually when you have to certify all these things and you have to update, usually when you finish this cycle, a new update has come. So.
Okay. Yeah, we have implemented what we call Product Security Lifecycle Management Plan. It's a complete governance document, including with the Product Security Control Plan, where we implement all these controls. This is now part of our, we call it BMS, Business Management System. We have implemented it. Our engineering and other teams start living to it, but we go permanently and do reassessment. And our job is to do a clear risk assessment, state the risk to the business, come up with mitigation activities, and reduce the risk levels. And then we come back again a year later, look again at the residual risk, make sure that we can add additional measures and put it down. So this is a complete cycle, and these tools, this PSLMP and the PSCP, is an in-house developed process and tool to support that. But we are happy to share if somebody needs some information, just contact me directly.
And I would like to take the opportunity to make a new question. So it's in reference to the Lieutenant Colonel about the how to integrate cyber and space planning process inside the operational planning process. As you said, there are new domains. Now we can say that we can have at least 2 new domains. We have 4 services. So what is the way that you think that is going to be implemented in the operational planning process? So it should be used like a special operational forces from the strategy level, or it should be used integrated in the services? How do you think that is going to be used?
In my opinion, it needs to be a fully integrated approach. Also in operations, it needs to be done by the key players. For instance, all the European Space Agency's spacecraft are operated by ESOC, ESA Operations Center in Darmstadt, Germany. So this needs to be implemented in their day-to-day operational plans also. They do a lot already of that and protecting that kind of activities. So this is a hand-in-hand process between industry, between the customer, between international organizations. Get it certified. If you apply specific equipment, you have to have certain certification levels. Talk to national space agencies. So we're talking to German DLR, to French CNES, and others. So this is a process, but this is just taking off. Yeah? No, you know, this is in the civilian world. This is just starting for the last 3 or 4 years, but it's a long way to go.
My experience is much more in the U.S. system, and I'm still learning NATO, but there's a separation, at least in the U.S., between the services, which are primarily an organized, training, equipped function, and then the organizations, the combatant commands that we have that really do the operational level planning, right? So they rely on the services to have forces provided to them. So the service side of it, I think there's a very real argument that you shouldn't have a military service without an ability to exercise some type of military force, right? Some type of force application. But at the same time, we're seeing these information age domains or capabilities. They can't get a seat at the table, right? So then it's a resourcing and funding issue. That's a little separate from, or not a little, it is separate from within the combatant commands building the operational plans. We've seen some people for some time with space expertise or cyberspace expertise, definitely electronic warfare, in the planning teams in these combatant commands, trying to do that. I don't know that it's fully functional. There's a lot of other competing issues. We heard a couple days ago from the J6, right? So if you're going to do cyber operations, where should that person sit? Should they sit in the 6? Or should they sit in the 3? If they're doing future planning, should they sit in the 6 or in the 3? I think there's an argument to say that if you're a cyberspace operator, you should be either in the 3 or the 5, right, doing planning as our operations. And if you look across, at least for the US, if you look across our combatant commands and then within the Air Force, our major commands, we've got a lot of different approaches out there. We've blended a 3-6 or a 3-5-6, or we've thrown the intel guys the 2. We have a 2-3-6, right? So we haven't made up our minds yet, right? All of the rest of the operators are in the 3, and all of the planners are in the 5, with the exception of the 6 guys. They're over in the 6 still, right? And so it's hard for me to make the argument we're fully integrated when they're in different staff structures, and as you travel around to different headquarters, the structures themselves change slightly, right? So I guess my argument would be at least one unifying staff structure. Putting the people in the 6 into the 3 and the 5 would be a way. I don't know. I'm sure people in the 6 would have disagreements with that. But then on the service side, can we find another way to get the folks who are responsible for these capabilities a seat at the table, an equal full seat at the table when it comes to discussing funding and resources? Because this stuff's expensive, right? I mean, we're not talking about low-cost capabilities. I don't know that we can do that without services, right? So in the US, we're looking at a separate space service. We are standing up a space command for across. We have a cyber command, but there's no talk about a cyber service. Within NATO, I think the Germans are the only ones now to have a cyber service, but it's a cyber and information service, and they don't have my understanding, they don't have a true ascension thing, right? So there's nobody who who enlists or is commissioned within the German armed forces as a cyber person. You're in the Army or the Navy, and you can go do an assignment as a cyber person in their service, but then you just as likely go back to your separate service, right? So we haven't figured this out yet. What's the right approach? But I think there is an argument that these folks need to have that seat at the table if you're going to treat them as true peer capabilities and operational domains. You can't keep funneling them through the traditional services because the funding's just not there, right? As an air chief, his primary responsibility is the air. Space and cyberspace are gonna naturally be secondary considerations, and they should be, right? So, you know, you need to have somebody that's sitting there next to those folks that can make those arguments, I think.
Thank you for very good questions. I just add from my point of view, I think this really illustrates this importance of interdisciplinarity, which is a term we tend to use in academia, but I think should be used much more widely. It's actually not possible to keep, that's one of the consequences of development of technology, which has nothing to do with technology only, but it is that we no longer have the borders between people doing one thing and people doing another thing. So, I think now you have earned your coffee break, especially the panel. Unless there is any short, quick question you thought about, then I think I can thank you, the audience, for your attention, and thank our wonderful panel. I think we give them another hand for a very interesting.